Any function when you can express it in the form of y is equal to f of x only, then it is called as explicit function. We know that derivative of e power x is e power x only and derivative of root x is 1 by 2 root x. So therefore e power root x is nothing but a composite function. What is the derivative of sine of any function? It is cos. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. In our previous session, we have learnt about the continuity of a function. That is, whenever RHL and LHL limits are equal, we say the function is continuous. Extending the topic, we are going to study about the differentiability of a function. So few of the derivatives of a functions you have already learned, that is some of the standard result must be remembered before going to learn about the differentiability of a given function here. So here we come across different types of differentiability of a functions. So before that, let's see what is differentiability. So the process of finding the derivative of a function is called differentiation, and that is the differentiability of a function. We have already learned from the first principle method to derive the sum of the function with its standard derivative. So let me write the derivatives of some of the functions which you have learned in your previous year. So that is, I'll take y is equal to f of x here, and the derivative of the function, that is dy by dx or f dash of x. This which we have already learned the standard result by first principle of derivative. So any function, any polynomial function in the form of x power n, its derivative is n into x to the power n minus 1. So for example, if it is x cube, it is 3x square. If it is x power 5, it is 5x to the power 4, like that. Any constant value, the derivative is 0. So the derivative of any constant function is 0. And sin x, it is cos x. For cos x, it is minus sin x. Tan x, it is secant square x. Secant x, it is secant x tan x. Similarly, I'll write y and here dy by dx. So cot x minus cosecant square x, cosecant x minus cosecant x cot x, log x, its derivative is 1 by x, e power x, it is e power x. So similarly, we can take root x as 1 by 2 root x, which we have obtained from this only. So these are some of the standard results which we have learned, that is the derivative of certain functions which we have already learned. Now using these results, here we are going to learn the differentiability of few more functions like composite function, implicit function, exponential function, parametric function, and the second order derivatives. So let's study these type of derivatives one by one. So before that, we also learned few rules to derive the functions whenever it is in the form of u plus v, u minus v, uv and u by v, which is given by Leibniz. So this is called as Leibniz rule of algebra of derivatives. So whenever we have any function in the form of u plus v whole dash, then u dash plus v dash. Similarly, u minus v whole dash is u dash minus v dash. Suppose we have any function in the form of sin x plus cos x. So we want to derive it. So what is the derivative of this function? So derive sin x separately. So u dash means derivative of first function. Derivative of sin x is cos x and separately cos x is sin x. So this is the derivative of the given function. So any function in the form of plus or minus must be derived separately. Next, uv whole dash. So the product rule is applied here. So u dash v plus uv dash, that is derivative of first into second function plus first into derivative of second function. So the third one is u by v whole dash. Here the quotient rule is used in this form, that is uv dash minus vu dash divided by v square. So these are the rules which learn to derive the function which is in the product or quotient form. Next is derivative of composite function, the function of a function. So whenever you have a composition of a function, for example, sin x is just a function, but sin x square is composition of a function, because here x square is one function, sin is one function. So sin of x square is composition of a function. So to derive these type of function, we use a rule called chain rule. What does this chain rule says? So whenever a composition of a function is given, for example, sin of x square, let me take the derivative of sin of x square. How to derive it? First, derive the function which is outside here. So what is which is outside here, and take the another function in the form of x only. So since you have sin x square here, consider it as sin x only. What is the derivative of sin x? Sin x is cos x. So write here cos x square. But x square is again one more function. So therefore derive x square separately. Again derive x square separately. So once you derive the function, the first function, the second function has to be derived separately, which is called as chain rule. So now derive it. So it is cos x square. What is derivative of x square? It is 2 into x. We know the derivative of x power n is n into x power n minus 1. So x square is 2 into x power 2 minus 1, which is nothing but 2x. So therefore it is 2x. Hence we will write this function as 2x into cos x square. So this is the derivative of the given function, and this process of deriving a composition function is called as chain rule. So let me take one more example, that is tan of 2x plus 3. Now the function is given here. We need to find the derivative of this function, that is d by dx of this function. So let me consider this function in the form of tan x only. So what is the derivative of tan x? The derivative of tan x is secant square x. So in the place of x, we have 2x plus 3. So therefore we will write the derivative here as secant square 2x plus 3. But derive the function inside the bracket also, d by dx of 2x plus 3. Because this is also one function. So therefore here now again it is secant square 2x plus 3 into, what is derivative of 2 into x? 2 into derivative of x is 1. So 2 into 1 is 2. And what is derivative of any constant? It is 0. So it is 2 plus 0. 2 plus 0 is 2. So therefore the answer is 2 into secant square 2x plus 3. Now let me take one more example. Y is equal to e power root x. We know that derivative of e power x is e power x only, and derivative of root x is 1 by 2 root x. So therefore e power root x is nothing but a composite function. So therefore first let me derive exponential function, and then we derive a polynomial function. So what happens here? Dy by dx. So if you take this in the form of e power x, then it is e power root x only. Then derive root x again, that is d by dx of root x. What is derivative of root x? It is 1 by 2 root x. So therefore here the function is e power root x divided by 2 root x. So this is a chain rule. So first you will derive one function, then you will derive one more function, again you will derive one more function. Like this, since it is in the form of a chain, this rule is called as chain rule, and it is used to derive the composite functions. So the next one is derivative of implicit function. What do you mean by implicit function? Before going to implicit function, let me explain you about the explicit function. We come across all type of function until here in the form of y is equal to f of x only. For example, if I say x minus y is equal to some pi. So what you will do here, you will convert y is equal to x minus pi. Then you will derive it. So this becomes dy by dx is equal to derivative of x is 1, derivative of constant is 0. So therefore the derivative of this function is 1. So any function when you can express it in the form of y is equal to f of x only, then it is called as explicit function. I'll give you one more example here. X minus sine xy is equal to y. Look at this function. Here you can't express completely y in the form of x only, because here see the second term, it is the composition of x and y function. So you can't take y completely in the variable of x. So these type of functions are called as implicit function. Then how to derive these kind of functions? So for example, let me take y is equal to sine xy. See here sine xy is again a composite function, and y we will write it as dy by dx. Next we will derive this function. What is the derivative of sine of any function? It is cos. So therefore this is cos of xy. Now again derive the given function with respect to x into y. So here we have two functions. One is x, another function is y. So apply the product rule. So here we get cos xy is equal to, apply the product rule here. What is the first function? First function into derivative of y. So if y is written, then it is derivative is written in the form of dy by dx. The same thing has to be applied here also. So the first function, derivative of y is dy by dx plus second function y into derivative of first is 1, because derivative of x is 1. So what happens here? Cos of xy into x into dy by dx plus y. Now here we get dy by dx. So if you take dy by dx as a common factor here, so clearly we'll get here 1 minus x into cos of xy. And here you are left with y into cos of xy. Just write this function in the denominator, then you are left with dy by dx. So this is the process of finding any implicit function. So you have to derive both x as well as y simultaneously, then find dy by dx of any given result. So let me take you one more example here. X square plus y square is equal to 36. So let us derive it simultaneously. What is the derivative of x square? It is 2x. Similarly, as in the case of x, we will take the same case with the y also. What is the derivative of y square? 2y. But only thing is, we have to write the derivative of y with respect to x. So dy by dx. See here x is differentiating with respect to x only. So therefore dx by dx is 1. So no need to write here. But here y is differentiating with respect to x. Therefore after writing the derivative of particular function, you have to write dy by dx whenever the function contains y as a variable. And here, what is the derivative of 36? Since it is a constant, the value is 0. Now we write dy by dx is equal to minus 2x divided by 2y. So 2 get cancelled. So therefore the value is minus x by y. So therefore what is the derivative of this implicit function? It is minus x by y. So like this, we come across many types of implicit function. Thus, whenever the function cannot be expressed with respect to x variable in the form of y is equal to f of x, then we call them as an implicit function. So then you have to derive the function both x and y simultaneously and try to find out dy by dx of a particular function. So next is here derivatives of inverse trigonometric function. Here you are not supposed to find out the derivative of all sine inverse, cos inverse function. Just remember the standard results of what is the derivative of sine inverse x, what is the derivative of cos inverse x, and use it whenever it is in the form of any composite function or any implicit function. So let me show you what are the standard results for the derivative of the following function. So the derivative of sine inverse x is given in the form of 1 divided by root of 1 minus x square. And for cos inverse x, it is minus 1 divided by root of 1 minus x square. This is all obtained from the first principle of derivative only. So no need to prove this result, just learn the standard results. Next, tan inverse x. The derivative of tan inverse x is 1 divided by 1 plus x square. And similarly, cot inverse x, it is minus 1 divided by 1 plus x square. So next, for secant inverse x, it is 1 divided by mod x root of x square minus 1. And similarly, for cosecant, just change the sign minus 1 in the numerator. So these are all the standard derivatives of all 6 inverse trigonometric functions. So a function will be given in the form of inverse trigonometric function. Solve it and apply these results. Then you can find the derivatives of the given equation or any given functions. So now we come across certain important functions of the form exponential as well as the logarithm functions. I have already told you the derivative of e power x is e power x. The derivative of log x is 1 divided by x. And remember, any function of the form log e power x is x or e power log x is also x, because log and exponential functions are invertible to each other. We have already learned from the invertible function, whenever two functions are invertible, if AB is invertible, then PA is also invertible, then it is equal to x only. So therefore, log of e power x or e power log x is one and the same, it is equal to x. Now let me take few examples here. Exponential function. Let me take e power minus x. So here is y is equal to e power minus x. How to derive y is equal to e power minus x? We know the value for only e power x. So therefore, let me consider this in the form of e power x only. So therefore, what is dy by dx of this function? It is again e power x only. But x is minus x here. So therefore, we have to differentiate it again. So that is derive minus x again. What's the derivative of minus x? It is minus 1. Derivative of x is 1. So minus x is minus 1. So the value become minus e power minus x. Similarly, let me take one log function. Y is equal to sine of log x. It's a composite function here. So therefore, clearly see here, dy by dx, sine of any function is cos of that function. But log x is one more function. Derive log. What is derivative of log? 1 by x. So therefore, the derivative of this function is cos log x divided by x. Now these are very simple methods which we use in the form of exponential or logarithmic function. Apart from this, we come across many types of functions in the form of x to the power sine x, y power x, or root of x minus 1, x minus 2, x square plus 5x plus 6. So these are few examples where we have to differentiate function and there logarithm functions are used, because the logarithm functions rules are certain such that we can simplify this first and then we find the derivative of a function, because we know that log of x to the power y can be written in the form of y log x as a product of two functions. That is why whenever x to the power sine x is given, so if we have y is equal to x to the power sine x, and when you apply log on both sides, what happens? Log y is equal to sine x into log x. Now we can derive the function. How to derive the function? What is the derivative of log y? It is 1 by y. And here we have two functions. One is sine x, another one is log x. How to apply the rule for this? So once log y is defined, you have to write it dy by dx, because I already told you y will become an implicit function here. So therefore log y is 1 by y. Therefore it is dy by dx. And here if you apply the product rule, first function into derivative of second plus second function into derivative of the first. So thus dy by dx is equal to y into sin x by x plus log x cos x. So this is the derivative of x power sin x. So whenever any functions is given in the form of a power x, so in the form of exponential function other than e power x, there we can apply logarithmic function, and using the rule log x to the power y, we can simplify the function, and then we can apply a product rule or any quotient rule or any composite function, chain function or derivative of any implicit function, and then find the value of dy by dx. So this is how where logarithmic function have very wide application whenever we have these kind of function. So I'll just show you here. Suppose you have y is equal to root of x minus 1, x minus 2 divided by x square plus 5x plus 6. So here, if you apply log on both sides, here it is log y. Since it is the whole function to the power half, it is half into log of x minus 1, x minus 2 divided by x square plus 5x plus 6. First simplify this. Here it becomes 2 into log y, or anything you can take. So here this is in the form of log x by y. Log x by means it is log x minus log y. So remember the rules of the log function. Log x power y can be written as y log x. Log x by y can be written as log x minus log y. Log xy can be written as log x plus log y. So using these rules, here I can write it as, this is in the form of x into y. So this is log x minus 1 plus log x minus 2. And since this is in the denominator, log of x square plus 5x plus 6. See, from this function, we simplified it, and now it is easy to find the derivative of this function whenever it is simplified. So therefore, log function is used to simplify a kind of functions like this. And then we can easily find the derivatives of functions. Next, we come across the derivatives of a parametric form. What is this parametric form? Whenever the third variable is introduced along with x and y. So here, suppose we have x and y as two variables, and x and y is expressed with the help of the third variable. Let me take it as theta now. Now, x is equal to a cos theta and y is equal to a sin theta. But I have to find what is dy by dx. So then how to find out dy by dx? Then dy by dx can be written as dy by d theta and dx by d theta. That is, x is differentiated with respect to theta and y is differentiated with respect to theta. And then if we apply here, we will find out dy by dx. Since x is equal to a cos theta here, differentiate with respect to theta. Whenever you are differentiating with the same variable, no need to find out d theta by d theta again. Because y is differentiable with respect to x, we have to write dy by dx. Now we have deriving with respect to theta only. So here it becomes a into, what is derivative of cos function? It is minus sine function. So this becomes minus sine theta. No need to find out here dy by d theta or d theta by d theta, because we are deriving only with respect to theta here. So next we have a function y is equal to a sin theta. So whenever a function is deriving with respect to theta, again here we have a sin theta. What is a? It's a constant. And what is sin theta? Derivative of sin theta is cos theta. So just derive it. No need to again write d theta by dy or dy by d theta again. Just use these two functions here. So what is dy by d theta? It is a cos theta. And what is dx by d theta? It is minus a sin theta. So once you cancel this function, it is cos theta by sin theta, and hence you will get minus cos theta. So this is how you're going to differentiate any kind of parametric function. So what do you mean by parametric function? Both x and y variable is expressed with respect to any third variable. It may be theta, u, v, any kind of a variable, and then you can differentiate with respect to the given variable and apply the rule here in the form of this. Just you are going to find out dy by dx. So next we come across a second order derivative. What is the second order derivative? Until here, I'll tell you, we have derived the function only once. So we can also derive any function multiple times. So second order derivative is nothing but deriving the same function 2 times. But how? Let me take an example. Y is equal to sin x. What is y is equal to sin x? We write dy by dx, which is cos x. Again derive this. That is written in the form of d square y by dx square. What is derivative of cos x? It is minus sin x. So this is nothing but the second order derivative. So here the order of the function is 1. So therefore we call it as a first order derivative, and here the order of this function is 2. So therefore we call it as a second order derivative. As I already said, any function with degree n can derive n number of times. So therefore it can be a multiple order derivatives also. So in your syllabus, you have only second order derivatives, that is finding the function twice. But you are not finding the function for the same function. Once you derive for the first order derivative, you will take that function as a new function, and again you will derivative to get the second order derivatives. So in general, there are many symbols to represent second order derivatives. So this is y, y dash, y double dash. So this is a function, first order derivative, second order derivative, or y, y1, y2. First order derivative, second order derivative, or y dy by dx, d square y, dx square. Again, the first order, second order. Sometimes f of x, f dash of x, f double dash of x. So all these here represents the second order derivative. All these symbols here represents the first order derivative, and this is the representation of any kind of functions. And second order derivative can be found to any composite function or any type of implicit function, inverse trigonometric function, or any parametric function. So these are the few kinds of functions, that is composite, explicit, implicit, parametric, as well as inverse trigonometric function. All these functions are derived with separate rules here, but it is one and the same way to find dy by dx. And in second order derivative, it may be any kind of function. Just derive the given function 2 times, then you will get the second order derivative. So we will take the problems in our next session, that is how to find the derivatives of any kind of implicit function or exponential function or composite function, logarithmic function, as well as parametric functions. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.